So this first part, we're going to look at radical equations. A radical equation is an equation containing terms with a variable in the radicand. So how to solve a radical equation? Isolate the radical expression on the right side of the equal sign, or on one side of the equal sign. Actually, I tried to do it on the left, but do whatever works best for your situation. Put all remaining terms on the other side. If the radical is a square root, then square both sides of the equation. If it is a cube root, then raise both sides of the equation to the third power. In other words, for an nth root radical, raise both sides to the nth power. Doing so eliminates the radical symbol. Solve the resulting equation. If a radical term still remains, which sometimes it will if you have more than one radical term, repeat steps 1 through 2 so you can isolate the radical again and then square it out or cube it out or whatever. So check solutions by substituting them into the original equation. This last part is actually really important because it's very likely in this case you'll end up with what we call an extraneous solution. So an extraneous solution is something that might work in one of the later versions of the problem, but it doesn't work in the initial version. Okay, so let's take a look at example 1 here. This is nice because we already have the radical isolated for us. So I'm going to, since it's a square root, I'm going to take that square root of x plus 3, square that side, and I'm also going to square the 3x minus 1. Now this is where most people get their radical equations wrong. The left is pretty straightforward. It's just going to be x plus 3. The right side, however, we have to FOIL that out. That creates a perfect square trinomial. So if you're not strong in this area, that's where it gets a little complicated. So if you remember, if you have a minus b, in this case, squared, it's a squared minus 2ab plus b squared. You can go back and do a minus b times a minus b, or a plus b times a plus b, and then work it out. I'm not going to do that because at some point we got to keep moving on with our development in math. And so I'm just explaining now that that's not always the efficient way to do it. I'm not trying to skip through things, but just to understand we need to keep advancing our skills. I'm just going to square this out, and we will have 3x will be squared minus 2 times the 3x times the 1 plus the 1 squared, and this negative here is this negative here. So we have x plus 3 equals 9x squared minus 6x plus 1. And I'm going to subtract the x from both sides and subtract the 3. So I'll end up having 0 equals, kind of out of space here, 9x squared minus 7x minus 2. So 9x squared minus 7x minus 2 equals 0. And I think that will factor. We can always use a quadratic formula. So 9 times negative 2 is negative 18. Factors of negative 18, that would be negative 7, would be negative 9 and positive 2. 9x squared minus 9x plus 2x minus 2 equals 0. So 9x squared minus 9x plus 2x minus 2. I'm going to group the first two together, group the last two together, and what are we going to have? So we'll have 9, I can pull out of the first pair, I can pull out a 9x out of the first pairing. So it's 9x times x minus 1 plus 2 times x minus 1. So I get x minus 1 times 9x plus 2 equals 0. And we're left with, if we set these equal to 0, x minus 1 is 0, means x equals 1. 9x plus 2 equals 0 means 9x equals negative 2, or x equals negative 9 halves. Now if we plug these back into the original, if I put 1 in there, I have the square root of 1 plus 3, is that equal to 3 times 1 minus 1? So the square root of 4 is equal to 2. That works. How about 9 halves? I should say negative 9 halves. So the square root of negative 9 halves plus 3, and 3 would be 6 halves, wouldn't it? Is that equal to 3 times negative 9 halves minus 1? Well, negative 9 halves plus 6 halves is negative 3 halves. So already we're talking about the square root of a negative equals, and I get negative 27 halves minus 2 halves. So clearly that's not going to work. So that means the negative 9 halves is the extraneous solution. X equals 1 is the only real solution. Okay. So x equals negative 2/9. Okay, so let's try these two solutions and see if they work. Let's try x equals 1. We'd have the square root of 1 plus 3. Is that going to be equal to 3 times 1 minus 1? Is the square root of 4 equal to 2? And that's true. How about 2/9? We're not going to like that one because it's got a fraction, right? So is the square root of negative 2/9 plus 3, and 3 would be what? How many ninths is 3? 27/9? Is that going to be equal to 3 times negative 2/9 plus, or sorry, minus 1? So on the left side, excuse me, it's going to be 25/9, which we know is 5/3. On the right side, 3 times negative 2/9 is negative 27/9. And minus 2/9 gives us minus 29/9. So clearly that's not going to work. And the fact that it was going to equal to a negative, a radical square root, principal square root, says it can't happen. So that's not a solution. That's extraneous. So this is our solution. Okay, so that was fun. Let's do another one of these. This time we have two radicals. And so we're going to do this twice. So we isolate one of the radicals. I'll subtract this. You know, I'm going to be strategic about this. And just for squaring purposes, I think it'd be easier to subtract this one first. 3x plus 7 minus the square root of 3x plus 7. So I isolate this. Square root of x plus 2 equals 1 minus the square root of 3x plus 7. So now if I square both sides, I get x plus 2 equals 1 minus 2 times the square root of 3x plus 7 plus this part, the square root of 3x plus 7 squared. So we have x plus 2 equals 1 minus 2 root 3x minus, or 3x plus 7, excuse me, plus 3x plus 7. So now we want to isolate this radical here. So we move everything else over. We'll subtract the 1 from both sides, subtract the 7 from both sides, and subtract the 3x. That gives us negative 2x. So we have 2 minus 1 is 1, minus 7 is minus 6, equals negative 2 times the square root of 3x plus 7. This one works nicely to divide by negative 2 on both sides. So I'm just going to come over here and continue working. And we'll have x, let me give myself a little more space because I'm going to need it. X plus 3. I divided negative 2x minus 6 by negative 2. So negative 2x divided by negative 2 is x. Negative 6 divided by negative 2 is 3, equals the square root of 3x plus 7. And now we square both sides. I'm going to write this again so people looking at the notes after the fact can see step by step as best possible. So this left side is a binomial squared, x squared plus 2 times x times 3 plus 3 squared equals square root of 3x plus 7 squared is just 3x plus 7. So we have x squared plus 6x plus 9 equals 3x plus 7. Subtract 3x from both sides. Subtract the 7 from both sides. And we will have, don't want to go too much on the next page, x squared plus 3x plus 2 equals 0. And that factors to x plus 2 times x plus 1 equals 0. So x plus 2 equals 0 means x equals negative 2. X plus 1 equals 0 means x equals negative 1. Now we're going to check these into the original. So for x equals negative 2, we have the square root of 3 times negative 2 plus 7 plus the square root of negative 2 plus 2, and is that going to be 1? So 3 times negative 2 is negative 6. Negative 6 plus 7 plus 0 equals 1. Yep, so the square root of 1 is 1. That works. Let's try the other one. And I have this negative 1. So we have this 3, the square root of 3 times negative 1 plus 7 plus the square root of negative 1 plus 2 equal to 1. Well, that's negative 3 plus 7. That's the square root of 4. It's the square root of 4 plus the square root of 1 equal to 1. 2 plus 1 is not equal to 1. So this would not be a solution. That's extraneous. Okay, and it's certainly a solution. Okay, that's the process here. And the next thing we'll talk about is rational exponents.